You are welcome to the physics class today. This is physics day 5. Physics day 5. I hope you are following the physics sharply as usual. If you are following sharply, you'll be able to get it as required. Now, today's class is going to focus on the Young modulus. Young modulus. It's just bordering on what we discussed earlier from the Hooke's law. From the Hooke's law, I gave the law according to Hooke's law that provided the elastic limit of elastic material is not exceeded, the force or the load applied on the material is proportional to the increase in length, that is the extension. Today we are going to take it in another dimension by looking at what we call the Young modulus. If I apply force on this wire, we will consider the cross-sectional area, the area of this wire. This cross-sectional area will be considered. We also consider the force I applied. Now, considering this area and the force applied in physics is called tensile stress. Tensile stress. If you are considering the cross-sectional area of this wire that I'm stretching together with the force applied, we are referring to the tensile stress. If we are to consider again the increase in length because of the stretching, the increase in length compared to the original length, we are talking about the tensile strain. Tensile strain. So, with this consideration coming from the Hooke's law, the stress, the tensile stress is proportional to the tensile strain. The force applied is proportional to the increase in length. So we can still have it in this way now, that the stress on elastic material is proportional to the strain. What is stress? Stress is equals to force over area. When we consider the force applied in stretching this, and then the cross-sectional area of the wire or the strain I'm talking about. That is the stress. What's of the strain? Strain is the increase in length of original length. The increase in length of original, that is the extension over the length. So the constant of the proportionality, or let me say stress and strain, if I want to put the constant now, I have that the stress is equal to the Young modulus strain times the strain. This Y represents the Young modulus, which is the constant. So the Young modulus now, if I make Y, this Young modulus now is the subject now, I have that the Young modulus now is equals to stress over strain. So we can state Hooke's law the other way around by saying that if the elastic constant of this wire is not exceeded, the stress is proportional to strain. The unit of stress is Newton per meter because the unit of force is Newton and that of area is meter squared, but it's down. This one has no dimension. Strain has no dimension because the units of increase in length is meter. The units of length is meter. You cancel out, it has no unit. So when you ask us which of these has no dimension, strain has no dimension, it's dimensionless. What I've told you now is this, that we can state Hooke's law the other way around by saying that provided the elastic limit of elastic material is not exceeded, that the stress is proportional to the strain. And I told you, when we talk of stress, we're talking of the force applied on the strain by the cross-sectional area of that strain. And the strain is the increase in length of the original length. That constant of proportionality is called the Young modulus. The Young modulus. Okay, thank you. Share, subscribe, drop your comment in the comment section. Thank you.